Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at branch circuit breaker sizing, wire sizing, and circuit descriptions in Design Master Electrical for Revit. If you are attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497. And our email address is support@designmaster.biz. So we're going to be looking at basically branch circuits in Revit and how Design Master interacts with them, because we layer a couple features on top of what Revit does, kind of replacing some of the stuff they do and adding to it. So we want to go over how that stuff all works. Most of this, the place to start is in the circuit edit command. So you want to start by looking at the circuit edit command. And here you can see where we specify our information about the circuits. So this is where you do your modifications to the circuits. Previously in Revit, you typically work in the panel schedule and you make your changes there, modifying circuit descriptions, setting breaker sizes. You do not want to do that when you're using our software, because we're going to overwrite all of those changes. Instead, you want to come in here, and if you have a change to the circuit description, you want to make it here rather than on that panel schedule. So if we pull up this panel schedule, let's pull up LP2, and we've got all those breakers and their sizes. So if we come in here and we replace this with something, and we adjust the trip size, that's how you would typically do that in Revit without our software. But with our software, if you do that and then you run in our calculate command to update all your calculations, it's going to overwrite those values with our own. So it goes back to that 20 amp breaker. And in this case, it didn't overwrite it because we haven't started using our circuit descriptions, but as soon as you put in one of ours, it will overwrite it. So if I come in here and take that description and use our software to overwrite it, it's going to replace what you've done here. So if you come in here and say, oh, I actually want this to be something different, and then you again run our calculate command, it's going to see that you've set it in our software and it's going to overwrite the value. So you don't want to do your changes in the panel schedules anymore. You want to do the changes through our software, either through circuit edit or some of the family commands we're going to be taking a look at. If you try and do your changes here, our software is going to overwrite it, and you'll get very frustrated and not like the software. So don't make your changes here. This is a viewing display only at this point. So with branch circuits, there are three things that we're really concerned about. That's the breaker size, the wire size, and the circuit description. All of those are set based upon what's connected to that branch circuit. So if I come back to my sheet here, for all of that, we're going to look at what devices are connected to choose the breaker size. So we'll take a look at the actual load on the devices, and we'll give you a breaker size and a corresponding wire size. And then if you have circuit descriptions set in the family using our software, we use that as well. I'm going to go ahead and run the Revit edit family command. I'm going to pull up this receptacle. And then in Design Master, I'm going to run the family edit command. And here we can specify the information in Design Master for this receptacle. In particular, we've got a couple different types. If it's just a generic branch circuit, we can leave it as a branch circuit device other. If it's an equipment connection, if it's a motor or something, we can specify an equipment connection and specify additional values there. Since this is just a receptacle, we'll leave it as other. And then we can overwrite the circuit description. So I'm going to call this a receptacle. And now every time we circuit this, it's going to pull in that description for us. So if you had different types of receptacles, if you had a dryer receptacle or something, you could set all that up in your family so that when your family is inserted and connected with our software, it's going to pull that information in. So we'll leave that as it is. And actually, we'll go ahead and come down here to the GFCI receptacle. And let's give that a different description. So now we're going to have our standard receptacle, which we'll call receptacle. Our GFCI receptacle, we'll give a different description there. Load all that into the project. we're going to run the circuit edit command. If you select the device on the drawing and you press circuit edit, it'll pull up the circuit for that device. That's an easy way to find it in our software. So we'll select that receptacle, press circuit edit, and you can see that it's updated all those circuit descriptions to have that new receptacle description that we inserted. And we're also including the room name, so that's included there as well. So all of those are just standard receptacles. So we have the description that says receptacle and then room name. If I come into this one and I change it from a duplex standard receptacle to the GFCI receptacle and run the circuit edit command again, you'll see that it added that additional description. So it says, okay, there's a GFCI receptacle. I should label that. There's some other receptacles. I label those as well. So you can see that we're filling in the circuit description and updating it based upon what you're actually connecting. So you're no longer having to make those changes, remembering to what you've got connected. It does it for you. You can also modify the specific instance in the model. So we've got the family settings that we've been looking at, and that controls all the receptacles. But if this specific receptacle has a different description, we can run the instance edit command. And we can say, okay, let's override the circuit description for this instance. Instead of saying GFCI receptacle, maybe this is a dryer. Probably not in this space, but it's just a different description. So we can use that. And so now instead of the circuit GFCI receptacle, we'll say dryer instead. Then we run the circuit edit command again just to see what our software is doing. And now it took out that GFCI receptacle description and put in dryer. So the software is using what we set in that instance for our circuit description. Generally, you want to work kind of at the device level to set your descriptions, because you set it at the device, and then the circuit it connects to, it's going to control that circuit for you. There are times, however, when at the circuit level you want to make some change. For example, this description is starting to get long. We've got dryer receptacle workshop 14, so it's getting longer than it needs to be. We've got these description settings here that we can use to update that. If we want to add additional information, we could. So maybe we want to say this is an existing circuit. We could do something like that. And so now we've got a value at the beginning of it. We can also do a value at the end. And that just goes here at the end. You can hardly see it, but there it is. It goes at the end before the room names still. And finally, you can always just replace it. If all the descriptions are too much and you just want to say this is what the description should be, you can put in a replacement, and then it'll just overwrite it with that value. So the replacement is kind of the catch-all for everything. It'll overwrite anything else that's there. You also have the option to turn the room name on or off. So if I get rid of this replacement, we can turn the room name off on this circuit, and now we'll get rid of it. That also can be controlled on the project level. So for each circuit, we have yes or no, and then we have default, which will just match what the project is set to. I'm going to set this one to yes, and then we go turn it off for the whole project. So that's under options. Here, include room names in circuit descriptions. We'll change it from yes to no. And again, run circuit edit to take a look at what it looks like. So all of these have lost their room names, but this one that I set to yes still has it. So that's how we control the circuit descriptions. And this is for branch circuits. The circuit description for panels is actually controlled in the panel itself. So if you look at this transformer here, we've got this panel connected downstream. That is not controlled here. You'll see this as modify and downstream electrical equipment connection definition. So to change this description, you'd go to PP1A, run the panel edit command on it, and make the change here. It's the description in upstream equipment. So by default, it'll be the device name, or you can customize it with additional information. So we could say panel PP1A. And now if we go back to the circuit edit command, you see that in this transformer, it pulls in that description. Staying on those distribution equipment settings, if I go take a look at the distribution equipment, I'm going to run the edit family command and take a look at this panel here. And so we can run the family edit for this panel, same as we did for the receptacle. We're going to change this to a panel type. You can also force an stream description prefix or suffix here. That way, if you always want to say panel, whatever the panel name is, you could do that. Or if you have additional information, you want to label the bus size or something else, you can include that additional information here. Load that into the project. And now all of those panels will have that as the prefix on their description. So if we run the panel edit, we take a look at one of those panels. So here's one of those panels. The default description is the device name plus that prefix that we specified. Looking at the breaker sizing and the wire sizing, that is controlled, if nothing else is set, by the load on the circuit. So if I come here I've got this cooling tower here. This has a big enough load to be interesting. This has 50 amps of load, 125% sizing, so we get a 70 amp breaker, 70 amp wire. So if you don't do anything else, you'll just size your breakers based upon the load. And then we do have options to override that in various ways. First of all, you can always, at the circuit level, just tell it what the breaker size and wire size should be. So if we select this breaker that we have here, we can go to the breaker trip size and we can force it to something different. So as the engineer, you always have the ability to just override anything we've given you. So we could change it to a 60 amp breaker, and we'll get smaller wires because it's a smaller breaker now. To set the conductor size, you can then come to the conductor amps, and if we wanted to change to aluminum wire, we could specify that here, and now we have a 70 amp aluminum feeder. We could also choose something bigger or smaller if you want to upsize for voltage drop or whatever need you have. So you can specify your conductor size here. You can also override the neutral and the ground and the conduit size. So the neutral by default is going to size to match the conductor, but you can override that to give it something else. If you want to double the neutral size or whatever you need for your specific situation, you can override that here. You can also override the ground, and then you can override the conduit size, and we do list the conduit fill. So if you give it something tiny, it's going to say, hey, your fill is probably too big. It'll let you do it because you're the engineer, but it's at least going to tell you what the fill is, and maybe you'll realize that you shouldn't be doing that. But you could set it to something bigger if you want to have it larger for future expansion purposes. We can also make a couple changes in the families themselves to handle these sizing the breaker and sizing the conductors. We'll run the family edit command again. And if I change this to an equipment connection, this is where we now have the ability in the family itself to specify the breaker and the wire sizing. So the original setting is going to be sized automatically based upon the load or the breaker. But we can override that and use basically the NEC motor compressor or motor settings to choose the breaker size. So I'm going to go ahead and change it to motor compressor, so be less than the MOCP. And you do need to specify the MOCP in order for that to be a valid setting. Otherwise, it's going to have to just size it based upon the loads. So we'll set that to 50. So previously we had a 70 amp breaker, so now it's going to force it to just be 50 because it doesn't need to be that big. And then the wire size, we can set it to size, again, based upon the motor compressor value. You can size it based on the MCA, the branch circuit selection current, or you can just size it based upon the loads or the breaker if you want to force it to those. Then we load all this into our project. And when we run the circuit edit, we'll see that we're giving that 50 amp breaker, but still the 70 amp wire. So it's pulling those from that family. We were looking at that in the family. You can also make those changes in the instance. So if you have a family set up with some sort of default value, and then on the instances, you can override it as appropriate. So you can see it's pulling in all those default values from the family, but you can override it with something else. In both cases, both in the family and in the instance, you can choose these automatic sizing. You can also just give it a value. If you want to say, okay, I want a 60 amp breaker for this piece of equipment, and I want a number 1 wire. Now it's just going to use that regardless of any of the other settings. And so we have our 60 amp breaker, our number 1 wire. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.